Now let us look at the question number 3 of the LeetCode contest. The question 3 was the minimum time to visit disappearing nodes. So the question says we are given with an undirected graph of n nodes. We are also given a 2D array edges where edges at the index of I denotes ui, vi and length I, which describes an edge between ui and node vi with a traversal time of length I units. It means it is a weighted undirected graph which is given to us. Additionally, we are also given with an array disappear, where disappear at the index of I denotes the time when the node I will disappear from the graph and we will not be able to visit it. Notice that the graph might be disconnected and might contain multiple edges. We need to return an array answer, where answer at the index of I will denote the minimum units of time which are required to reach node I from node 0. It means node 0 is our source node. If any node is unreachable from node 0, then answer at the index of I should contain -1. So I hope the language of the question is pretty much simple and it is very much clear to you all. So whenever we see it's a graph question and it is saying we need to return the minimum units of time required to reach node I. The very first thing which clicks to our mind is the Dijkstra's algorithm. The same thing we are going to apply in this question, and the question will be easily solved. But the thing which is given to us is here is disappear at the index of I, which is denoting the time when the node I will disappear. So first of all, let us understand this particular question with the help of an example. So this was the graph which is provided to us. The source node is 0. We have to start from 0. So it is very much clear to reach from 0 to 0, we need 0 units of time. So answer at the index of 0 will contain 0. Now to reach 0 to 1, which is the minimum path. If I reach directly from 0 to 1, the time required is 2. If I reach via 2, that is 0 to 2, then 2 to 1, the time required is 5. So the minimum time is 2. But I can clearly see that disappear at the index of 1 is giving us 1. It means after 1 unit of time, that particular node will disappear. And the minimum time which is required to reach to node 1 from node 0 is 2. So it means when we will reach node 1, it will already get disappear. So we cannot reach node 1. So that is why we will answer at the index of 1 will contain -1. To reach 2, the minimum time required is 3. We can reach 2 via 0 to 1, then 1 to 2. It will require 3 units of time. And to reach from 0 to 2 directly, it will contain 4 units of time. So the minimum is 3 units of time. So answer at the index of 2 will contain 3. So answer, I don't know why 4 is written over here. For node 2, we need at least 4 units of time to traverse. Yeah, 4 units of time is required. Why? Because we cannot travel via this path 0 to 1 and 1 to 2. If we will travel via this path, what will happen is we cannot reach to node 1 because node 1 will disappear at 1 unit of time. So there is only one path to reach node 2, that is we can reach from 0 to 2 directly, which require 4 units of time. So that is why it will contain answer at the index of 2 will contain 4. So we are going to apply Dijkstra's algorithm. Just see how we are applying this. First of all, we have constructed the adjacency list for our graph. Vector pair, since it is a weighted graph, so we have taken as pair int comma int. This denotes there is an edge between edges at the index of I 0, edges at the index of I 0, to edge is at the index of I 1, with its weight as edges at the index of I 2. Since it is an undirected graph, so we have constructed the adjacency list in the line number 7 to line number 11. We have made one answers variable to store our final answer, which is storing the number of minimum units of time to reach from node 0. Initially, we have initialized each and every index with the maximum value, that is int max. So vector int answers n comma int max in line number 4. After that, we have made one min heap. Why we have made one min heap? So that always the minimum element is on the top of our stack. So that is why we have made one min heap. I hope you all know, while when we apply Dijkstra's algorithm, we always make one min heap. We have pushed in our heap 0, 0. The very first element is denoting the distance and second element is denoting the node. So in order to reach node 0, we require 0 units of distance. So that is why we have pushed 0, 0, and we have updated the value of answers at the index of 0 to 0. Because to reach from node 0 to node 0, we require 0 units of time. Then we have applied while not equal to pq.empty. The very first element of our priority queue is giving us distance. So int distance equals to pq.top.first. The second element of our priority queue is giving us the node. So int node equals to pq.top.second, and we have popped it out. If distance is greater than answers at the index of node, it means we have reached that particular node in a less units of time than distance. So we can directly continue the loop. We need not to iterate further. If there is a better possibility, then we will iterate further. So we have made one vector v1 adjacency node. It will contain all the nodes which are connected to this particular node, which is in our priority queue. Then we will iterate. This new distance will give us the distance which is required to reach from node 0 to that particular node via this node. So this new distance will contain that particular distance. If this new distance is lesser than answers at the index of v1 at the index of j dot first, as well as if disappear at the index of v1 at the index of j dot first is lesser than or equal to new distance. What is this line denoting? This line is denoting if the distance, this new distance, suppose it is 5, and this node will disappear in 4 seconds. So in that case, this condition will become true. It means we cannot reach that particular node. So we will update the value of answers to -1. It means this node is unreachable. Otherwise, what we are going to do, we will push that element in a priority queue, and we are going to update the value with new distance. It means we can reach that particular node in that particular distance. So we are going to update this particular thing. Once this loop ends, we will check if any of the indexes is still int max. It means we cannot reach that particular node, and we are going to change it with -1. And at the end, we are going to return answers. So this is the thing which we have applied. We have just applied the Dijkstra's algorithm in this case. The main thing is, if we will not apply this condition, if distance is greater than answer at the index of node, what will happen? The code will result in TLE. I think if you have attended the today's contest, then TLE was coming for most of the participants. So this is the main condition which one should apply from line number 21 to 24. That is, if suppose to reach one particular node, we are already reaching a particular node at distance 4, and this distance is 5. So it means we will always get a distance which is greater than the previous one. So we need not to iterate. We need not to continue these steps. We are just apply one jump statement, that is continue, so that our time will be saved. So this will give us better time complexity. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.